Hello, everybody. All right, in this video, I'm going to teach you guys how to identify a function strictly from looking at the table. All right, let's first explore linear functions. So when you look at a table, how you can tell it's a linear function is, well, first of all, your x values are all increasing by an increment of 1. So if you see this first table right here, it starts off with 3, then it's going up by 4, 5, 6, etc. But when you look at your y values, you'll see that you're adding the same number every time to get the next value, or you're subtracting the same number every time to get the next value. As you can see in this first one, 40 plus 5 gives me 45, 45 plus 5 gives me 50, and another 5 gives you 55, etc. That's how you can tell it's a linear function. Now, also too, what I want to mention is that you can look at some of these tables and figure out what the y-intercept is. All you got to do is look to see where x is 0, and then it gives you the value for y. That's going to be the y-intercept. For example, as you can see, x is 0 right here, right? And the y value is 2. So therefore, my y-intercept will be 0, 2. This table down here, it also has a y-intercept. Happens to be the same number. So the y-intercept will be 0, 2. Now, if you look at that first table, can you tell what the y-intercept is? Nope, and that's okay. Like I said, sometimes you can and sometimes you can't. Now, quadratic functions. All right, with these tables, one thing you're going to notice is that some numbers are going to repeat or kind of mirror each other. And so you'll hear people say that the table is symmetric. Like, for example, if you look at this first table right here, after about right here, have you noticed that the y values kind of repeat? It says 6, 0, -4, -6, and then -6, -4, 0, 6. They kind of mirror each other. That's how you can tell it's a quadratic function. Same thing here. After about right here, 6, 3, 2, and then 3, 6, it starts to repeat again. And by the way, this 0, 2 is the vertex, because if I had kind of just eliminated this out, you see how it's 6, then 3, then 3, then 6? That's how you can tell it's quadratic. Look at this last example down here. Same thing. It starts to repeat after -1. So that's how you can tell it's a quadratic function. And I so happen to circle what the y-intercept was in both of those tables. The y-intercept here is 0, 2. Y-intercept here is 0, -1. And then the first one is 0, -6. And the last thing we're going to look at is exponential functions. How you can tell it's an exponential function is that when you look at the y values, they're either increasing or decreasing by you multiplying the same number every time. As you can see in that first table, I'm doing 7 times 2 to get 14, 14 times 2 to get 28, 28 times 2 to get 56, etc. So whenever you're multiplying the same number every single time to get the next number, it's an exponential function. And just to keep the same momentum, the y-intercept of this first table will be 0, 7. And that's it.